Okay, Assalamualaikum and good morning everyone. Okay, so welcome to our first lecture. In this semester, session has changed method of teaching. So we just only explain about the cognitive learning, CLO1, means that mood remembering, and CLO2 for understanding. And the otherwise C3 and C4, CLO3 and CLO4, we cover in a tutorial. In tutorial, you are more focused on calculation, explanation, and problem solving. Okay, so let's start with the chapter 1 for electrostatic. We can see, and in this topic, so there are 4 subtopics, which are Coulomb's law, or we can rewrite as electrostatic force. Okay, next is 1.2 electric field, 1.3 electric potential energy, and inside the electric potential energy you can also cover the electric potential energy. Okay, then 1.4 is charge in a uniform electric field. Okay, so now this you change to chapter 1. Okay, so we look at 1.1 Coulomb's law. At the end of this topic, the student should be able to state what is the Coulomb's law, or you can rewrite as electrostatic force, given by equation F is equal to Q times Q over 4 pi epsilon naught R square. Okay, also equal with K QQ over R square. In this case, K here is constant value for electrostatic force. K is also equal to 1 over 4 pi epsilon naught. Okay, so next, Coulomb's law, or we call it as Coulomb force. Okay, the magnitude of the electrostatic force F between 2-point charge Q is proportional to the product of charge and inversely proportional to the square of the distance between them. So meanings that F is directly proportional with 2-point charge Q1, Q2 over is inversely proportional to the distance between them. Distance between these two charges is R12. Okay, so mathematically, we can rewrite this relation as this form. F is equal to K QQ over R square, because K is the electrostatic Coulomb constant. Is that the constant value? Law we change into equation, we must include the constant value. So we call it a constant value here is electrostatic constant. Okay, so you can rewrite also this equation as F is equal to K Q1 Q2 over R square. Either one is okay. So why we have two type of Q here, capital Q and small q? Actually, we want to differentiate between capital Q and small q, because capital Q we also known as the point mass, and then small q as a test mass. Okay, test mass is mass that always tested by a point mass. Okay, so later we can see the example for sketching of the electrostatic force. Okay, so F is magnitude of electrostatic force. R is the distance between 2-point charge. Depends on the charge that you choose. 1, 2, so means that if let's say the charge between them is 1, 2, so R distance must be R between 1 and 2. If you choose charge 3 and 4, so means that R distance between charge 3 and 4 square. Okay, next is K. K is electrostatic Coulomb constant, is given by 9 times 10 to the power of 9. Okay, next is epsilon naught, is the permittivity of the free space. 8.85 times 10 to the power of negative 12. Okay, so the Coulomb's law, or sorry, the electrostatic force or force is the vector quantity. Force is vector quantity, so meaning that force have magnitude and direction. That's why when you want to solve problem for electrostatic force, you must include with your diagram of the direction force, diagram of the forces. So you can include. And then why? Because the direction is based on the diagram. Okay, magnitude is come from your calculation. Okay, so then the unit is Newton. The sign of the charge can be ignored. Why the sign of the charge can be ignored? Because the direction of this force you can determine by using sketching or drawing. Okay, so the sign of charge can be ignored, must be ignored. So kalau you masuk dalam calculation, make sure that nilai Q tu tak boleh negatif lah. Okay, so mesti nilai yang positif. Tak boleh ambil kira charge yang negatif. Okay, when substituting into the Coulomb's law equation. So next, sketch the electric force diagram and apply Coulomb's law for the system of point charge. In this lecture, we just only sketch the electric force diagram. You just show how to sketch. Okay, so you can see here, first diagram here, we have both positive charge. Okay, when you have both positive charge Q1 and positive charge Q2, what will happen for these two charge? The two charge will experience a repulsive force. Force Q2 will be to the right, and force Q1 act on Q1, the force act on Q1 will be to the left. Force act on Q2 will be to the right. Okay, how to naming these forces? Okay, we can naming these forces F, let's say F12. Why F12? Because force exerted by 1 on charge 2. On charge 2, you draw the arrow on charge 2, meaning that charge 2 is the test mass. Point mass is Q1. Let's say if you want to determine the force act on Q1, so Q1 must be as your test mass. So, how to naming the forces? F21. Force exerted by 2 on charge Q1. On Q1 means that 1 is test mass, charge 2 is point mass. If both are negative, also acting force is repulsive force. Okay, next is, let's say Q1 and Q2 are charged in opposite sign, force acting on it. Q1 is negative charge, Q2 is positive charge. So, what the force acting on these two charge is attractive force. That's why the arrow is attract to each other. So how to naming the forces? Same as before. Force to 1 means that force exerted by charge 2 on charge 1. On charge 1, so 1 duduk di belakang, 2 duduk di depan. Okay, same goes with Q2. F12 means that force exerted by charge 1 on charge 2. So how about the value? The value of F21 is equal with the value of F12 because the magnitude is same, because the number here is same. But they are in opposite direction. F12 is to the left and F21 is to the right. F12 is to the left, so should be negative here. Just for example. Okay. So let's look here. If let's say we have more than 3 charge. Okay, sketch the electric force on charge Q2. Charge Q2 means that we only see on charge 2. Okay, what will happen to charge 2? Charge 2 act as a test mass. Okay, the other charge will be the point mass. Okay, so you react first with the Q1. Okay, Q1 and Q2. What the relationship between charge Q1 and Q2? Q1 and Q2. Q1 is charge positive, Q2 is charge negative. What type of force? Okay, attractive force. Okay, so this one like this. Okay, attractive force. And then how to naming the forces? Here will be F12. Why F12? Because the test mass is 2. So you letak kat belakang. Okay, F12. And then naming for this one will be F21. Because charge here is 2. The test mass is 1. But the question asks you to determine on charge Q2. So we don't look at these 2 charge. Okay, we look on Q2 charge. Now Q2 as the test mass. Okay, so now next Q2 and Q3. What the relationship between Q2 and Q3? Also attractive force. Okay, so how to naming charge? Here will be F32. Why F32? Because the test mass is 2, the test charge is 2, the point charge is 3. So the naming is force 32. Force exerted by charge 3 on charge 2. The naming for this force is F23. But the question asks you to determine on charge Q2. So we draw back this diagram. So the answer should be like this. F12, F32. Okay, this is diagram, and then we will calculate for the resultant for these forces. Okay, this time I just teach you how to sketch the electric force diagram based on the test mass given. Okay, same goes with this one. This one we call it as 2 dimension. Why 2 dimension? Because the forces we draw is not laid down on the same axis, in the different axis. Okay, alright, so yang ni you akan buat resolving force lah, macam yang ada cos dengan sin tu. But it's okay. Okay, untuk A ni you dapat dia same axis, right? Axis negative x and axis positive x. So the way to determine resultant is very easy, because F resultant you just only add up F12 plus F32. But we consider the direction based on drawing, right? So based on drawing means that F32 adalah ke kanan. So ke kanan selalu kita assume positive. F12 is to the left. So kita akan assume kat sini negative. Okay? Alright. So you bila you kira you akan dapat jawapan lah. Macam tu. So don't worry, because all this you will learn in tutorial class. Okay? So let's say we try this another example. Draw the direction of the electrostatic force act on the charge Q2. Charge Q2. How about I change this one? Q3. Let's say Q3. So here, how to draw? Okay, first you check the relation force between 1 and 3. Okay, tutup yang 2 ni. Close these two first. Okay, what will happen to 1 and 3? Negative, positive, the charge will be attract to each other. Attract. So, what the naming of this force? F13. Yang kat sini saya takkan tulis sebab saya tak mau cari dekat sini. Saya nak cari yang dekat Q3 sebab saya dah tukar soalan kepada Q3. Okay, bila you dah lukis yang ni, so now you buka balik yang ni and then yang ni kita nak tengok. Okay, so now what the relationship between Q2 and Q3? Okay, positive, positive, the forces will be repel. Is it? So repel. So what the naming for this force? F23. Why 23? Because the point charge is 2, the test charge is 3. Okay. So the direction of the electrostatic force act on the charge Q3, the answer will be positive Q3 F23 F13. Okay, so when the question asks you to determine the value of the electrostatic force, then you will continue with the calculation. You can calculate F13, you can calculate F23. Okay, so let's say I choose only one example. So F13 means that you use the formula K Q1 Q3 over R13 power of 2. If let's say you calculate F23, K Q2 Q3 over R23 power of 2. So you just substitute the value of Q1 Q3 Q1 Q3. Okay, Q1 is negative, right? So you not consider the negative sign. You just only put the value. Okay, R13 means that 13. 13 means that distance here until here is 1R. R13. R13 is power of 2. Okay, for 23, force for 23, Q2 is positive, Q3 is positive, and then R23 is the distance between charge 2 and charge 3. And then you can calculate. When you get the value, you can use the resultant. Because F13 and F23 is laid down at the same axis, positive x and negative x, means that same axis, both are x component. You just determine F total is equal to F13 plus F23, but F23 is to the right, so positive. F13 is to the left, so you need to put the negative here lah, just like that. Okay, so the other you can try by yourself.